Hey class, Mr. Houston here, back and better than ever for another exciting episode of Geometry Notes. We are moving out of Chapter 2 and jumping into Chapter 3, which is all about parallel and perpendicular lines.
Say hello for me.
Mr. Brooks is here with me too. He says hi and hope you all had a wonderful evening and enjoyed your Chapter 2 test. As we get started here with identifying pairs of lines and angles, Chapter 3, Lesson 1. So here we go. Some vocabulary to get rid of here first. Two very important things to know here. We're talking about parallel and skew lines. Parallel lines, we know, are two lines that do not intersect. We are now attaching another part of a definition to this here and saying that they have to be coplanar, meaning they are in the same plane, because we now have what we call skew lines, which are two lines that do not intersect, and they are not in the same plane. So just because two lines do not intersect doesn't make them parallel. If they're in the same plane, they're parallel. If they are not in the same plane, they are skew. So to kind of take a look here at a picture and some notes that go along with it here, we'll go through everything here real quick. M and N, not the candies, they are parallel. Okay, these little arrow marks here, the little red arrows, that means that M is parallel to N. Okay, M and K are skew. Notice they'll never intersect, but they're not in the same plane, so we can't say that they are parallel. Planes can be parallel. Plane T is parallel to plane U. And then finally, lines K and N are intersecting, and there is a plane containing them. That's not shown. I don't know what we're going to use that for, but anyway, the book wanted you to know that. So lines K and N are intersecting, and there's a plane that contains them both, but we don't see it. Okay, so let's just start off with an easy one here. Let's take a look at a picture, and let's try to identify different parts with our vocabulary words. We want to look for lines that are parallel to CD, line CD, and they contain the point A. So just so everyone knows what we're looking at here, we're looking at this line here, and it's got to contain this point right here. So the first one is any lines parallel to CD that contain point A. So they have to be on the same plane, and they have to never intersect. So in this case, the only one that would apply to, that would meet this criteria would be line AB. There are other lines that are parallel to CD, but AB is the only one that contains the point A. So if we look here, they're parallel, they're on the same plane, they'll never intersect. Okay, part B, lines that are skew. So lines that, again, aren't going to intersect, but they're not on the same plane. So if we look, CD is here. We have point A here. So a line that will never intersect with CD and is not on the same plane is AH. And is there any other ones here? Let's see, AH. Oh, and then we have AG here as well. It is, again, never going to intersect with CD, but they're also not on the same plane, so AG. Okay, number C, right, letter C. Are there any lines perpendicular to CD and contain the point A? Again, remember perpendicular means to intersect at a right angle. So we need to look at CD, look at any right angles that are made. If these two are right angles, then these two up here will be right angles. We have to contain point A, so there's only one line that's perpendicular to CD that contains point A, and that is AD. And last but not least, letter D. Any planes parallel to plane EFG and contain the point A. So EFG, if you're kind of struggling to see what that is kind of the bottom of the box here. So if there's any planes parallel to that one that have to contain point A, so if it's the bottom of the box, the only one that's going to be parallel to that is going to be the top of the box. And to name that, we have to name it with 3 points. And so however you want to do it, maybe we say ABC, Maybe we say ABD. However you want to do it, just know that it has to contain point A. Okay, so that's just identifying some of the relationships between lines and planes in that given picture. All right, so your new best friends now, these postulates, we need to add these two more to it, the parallel postulate and the perpendicular postulate. Basically, all they're saying is that if there is a line and a point not on the line, so we have line L and a point not on that line, point P, there is only one line that is parallel to that given line through that point. So there's now only one line that goes through P that is parallel to line L. And postulate 14, perpendicular postulate, if you have a line L, and a point not on the line, point P, there's exactly one line that goes through point P that is perpendicular to that line. So just there's only one line that goes through point P that will make it either parallel or perpendicular to line L. So go ahead and make sure we add those to our postulate page, which is growing longer by the day. If you need more pieces of paper to write those down on, pick them up in class. All right, flip it on over to the back side. So we are now going to identify parallel and perpendicular lines. So just to, your picture probably did not print out nearly as well as this nice colored picture is here. So let's just label a few of these so you can hopefully see them. This is point B right here. Point B, point C, D, M, and A. Actually, we'll call those lines. These are all lines. Line C is going to be this one right here. Line B is this one right here. This is line A. And this is line, well, can't really see where all of them are. This is actually a terrible picture here. Oh no, they are points. I'm sorry. Don't mind me. A little early for this. There are actually points on there. And I guess there's even a point F down here. Oh, there's an F and an E. Well, find something new every time. All right, so we are simply going to take a look and try to name a pair of parallel lines. So remember, they have to be on the same plane and they have to never intersect. So if we look here closely, we need two lines that will never intersect and that are on the same plane. We're going to just assume they're all on the same plane. So if we look here, I would say it looks like these two roadways here eventually are going to intersect at one point. Okay? So I would say the two lines that will not intersect are line MD and line FE. So how we would write that is we would write it like this. So line MD is parallel to line FE. You don't have to write is parallel to, you can use those two little lines right there. But that means they are parallel. Okay, letter B says, name a pair of perpendicular lines. The key is that we make sure that we have a 90-degree angle. So this is our 90-degree angle right there. So that would mean that line MD is perpendicular to, remember that upside down T, line BF. Okay, we can't assume anything else because there's no other 90-degree angles, at least not at this point, but we will learn that here very shortly, hopefully. Okay. All right, the last example here is asking us, is FE, so this line down here, parallel to AC? Okay, AC. So obviously, just by looking at it, we can see that eventually it looks like these two lines are going to intersect out here somewhere. Okay, so we are going to say no, but because this is math and I like to get technical about it, we are going to talk about the fact that point M is on line AC, and according to the parallel postulate, there's only one line through point M that is parallel with FE, and that line was MD. We talked about that in part A here, so we can't have a second line through point M that is parallel to FE. So yes, it's no because by the looks of it, they're going to intersect, but it would be no due to the parallel postulate that was on the last page. Okay. The last thing we're going to talk about is this thing called a transversal. And a transversal is nothing more than a line that intersects two or more lines at different points. There are special properties that hold true when something is cutting or a line transverses two other lines. There are certain properties that hold up according to our angles formed by transversals. So we have two lines that's cut by a transversal. You see the little line T, and we need to understand what these angles are in these given spots. So the first one is corresponding angles. So the way I look at corresponding angles are they are in the same spot on different lines. So they're on the top right-hand side of both lines. So those would be corresponding, or they would be in the bottom left-hand side of both lines. They're in corresponding spots. Alternate interior angles. Again, much like everything else in math, the definition is in the word. So they're on alternating sides of the transversal, and they're inside. They're in between the two other lines. So opposite sides of the transversal and inside the other two lines. Alternate exterior, again, alternating sides of the transversal. Now we are on the outside of the other two lines. And consecutive angles are on the same side of the transversal and inside the line. Okay? So there will be some properties in the next lesson about these, but for now I just want you to be able to identify what each of these are. So we are going to say, for example 3, that our transversal is right here. This is our transversal, and so I want us to identify all the corresponding angles, alternate interior, alternate exterior, and consecutive interior. So let's start first with corresponding. So these are our two lines. So what we're going to be looking for are angles in the same spot but on each of those lines. So the first one I'm going to say is angle 1 and angle 5. Those are in corresponding spots. So angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. They're in corresponding parts on those two lines. Next will be alternate interior. So again, we're talking about inside, in between the two lines and on opposite sides or alternating sides of the transversal. So I would say angle 2 and angle 7, and angle 4 and angle 5. Part C is alternate exterior. So instead of being in between the two lines, we're on the outside. So angle 1 and angle 8, and angle 3 and angle 6. And finally, we're talking about consecutive interior. So we're inside the lines and we're on the same side of the transversal. So angles 2 and angle 5, angle 4 and angle 7. All right, so a lot of information coming at you today. I apologize, the video is a little longer than I want it to be, but a lot of good information, a lot of stuff we're going to use here throughout this chapter.
He's really not sorry.
Like Mr. Brooks said, I am really not sorry, but I'm going to tell it to you anyway. So have a good one. Bring any questions with you to class. We'll see you then.